So we have a rancher who wants to fence in an area of 2.5 million square feet in a rectangular field and divide it in half. And we need the shortest length of fence that the rancher can use. So we're trying to minimize the amount of fence. So this is one where drawing a picture would be very useful. So here's our rectangular region, and perhaps we call this X and this Y. Without even going any further, we already know our constraint. Because the area is 2.5 million, X times Y has to equal 2,500,000. Now what they're going to do is drop in down the middle another fence. So the total length is the distance along the sides, which we know normally would be 2x plus 2y. But we've got another x right here. So the total length is actually 3x plus 2y with the diagram that we have. So now let's get L all in terms of one variable. So we'll solve our constraint. So x is going to be 2.5 million over y. We'll plug that into our L. So, and multiplying it by 2 is actually going to make 5 million in the denominator. 5 million in the numerator. So I'm just going to go ahead and combine those two steps. So again, the 5 million came from the 2.5 million times that 2 there. Oh, shoot, I solved this for x. Let's solve it for y. Y equals 2.5 million over x. Sorry for the mistake there. Over x. And now we solve by taking the derivative. We've got a lot of practice at this point of derivatives, so I'm going to go through this one a little bit quickly. Derivative of 3x is 3. Derivative of 5 million over x is negative 5 million over x squared. To check that, you can run your power rule. Now what we do is we take our derivative and set it to 0, and we solve. So I would add this term over to the other side. So I got 3 equals 5 million over x squared. And then I'll multiply both sides by x squared to get the variable out of that denominator. So I got 3x squared. Solving that is going to give me x equals 5 million, one more 0, over 3, the square root of that. We only need the positive because we're talking about a length, which is approximately 1,291 feet. Now, taking that value and plugging it into our equation up here, that'll give us our y, which is going to be approximately 3,873 feet. And then plugging those values into the equation we found for L right here gives us that, let's use approximate since we did round, 11,619 feet.